Welcome to Lecture Online. In this video, we're going to try to find the integral of the cosecant square of x. And if you learned anything from the previous video, we might have a hint. How about doing the following? Let u equal, instead of the tangent of x like we did in the previous video, we're going to try the cotangent of x. In that case, of course, the cotangent of x is equal to the sine, not the sine, it's equal to the cosine of x divided by the sine of x. And then if we take the derivative of that, du dx, with respect to x, that is equal to the denominator, sine of x, times the derivative of the numerator. The derivative of cosine is the negative sine, minus the numerator, times the derivative of the denominator, which is the cosine of x, all divided by the denominator squared. We can simplify that. We can write this as du dx is equal to the negative sine square of x minus the cosine square of x, all divided by the sine square of x. And then in the numerator, if I factor out the negative 1, du dx is equal to minus 1 times the sine, that's the sine here, the sine square of x plus the cosine square of x. The whole thing divided by the sine square of x. And of course, the sine square of x times plus the cosine square of x is equal to 1. So we see that du dx is equal to minus 1 divided by the sine square of x, which is equal to minus the cosecant square of x. If I now multiply both sides by a dx, I get du is equal to minus the cosecant square of x times dx. Or, if I multiply both sides by negative 1, I can write minus du is equal to the cosecant square of x times dx. The reason why I did this last step is because when I look up here, I see the cosine square of x dx, which is equal to minus du if I let u equal the cotangent of x. So substituting that in, I get this is equal to the integral of minus du. The minus can come outside integral sign. This is minus 1 times the integral of du. And of course, that's the easiest integral in the world. The integral of du is equal to u minus 1 times u plus a constant of integration. And since u is equal to the cotangent of x, this is equal to minus the cotangent of x plus a constant of integration, which is the integral of the cosecant square of x dx. Again, the way we solve this is to kind of suspect that that's the case, and then we simply make the substitution, let u equals the cotangent of x, and that's how we solve a problem like this.